Okay, this is problem number 4 for volume and surface area. The problem reads, a pharmaceutical company is designing a pill capsule for a new medication. The pill is shaped like a right cylinder with hemispheres on either end, as shown in the diagram below. And I have outlined the diagram to make it easier to see. What is the total exterior surface area of the capsule? And part B says, what is the volume of the capsule? So for part A, we're dealing with surface area. Now this capsule is not really a three-dimensional shape that we know. It's made up of a couple shapes that we do know. What it's made up of is, it tells you in the problem, and you can see it in the diagram, it's made up of a right cylinder, and it's made up of hemispheres on either end. And a hemisphere is half of a sphere. So when we're talking about in part A, what is the total exterior surface area of the capsule? Well, the surface area of the capsule, that is the surface area of this hemisphere plus the surface area of the middle part plus the surface area of the other hemisphere. And in reality, two hemispheres, when you bring them together, it actually equals one sphere. So for the ends, that's the surface area of one sphere. And for the middle, it's going to be the cylinder. But is it the whole cylinder? Or is it just the midsection of the cylinder? It's just the midsection, and that's what we call the lateral area. Because we don't want the entire surface area, because the bases of the cylinder, which are circles, are actually inside of the capsule, and we don't want to count that. We just want to count the lateral area. So I'm going to say the lateral area of cylinder. So when we calculate the surface area of one sphere, and when we add that to the lateral area of the cylinder, we're going to get the surface area of the entire capsule. So let's do the surface area of the sphere. The surface area of the sphere, which we know, it's on our formula sheet, 4 pi r squared. 4 pi r squared. So if I plug in r in my diagram, it looks like the diameter is 6, which means my radius is 3. So this is 4 pi times 3 squared, which is 4 pi times 9, which equals 36 pi. So my surface area of the sphere is 36 pi. Okay, what about my cylinder? Well, let me show you this little cylinder that I have here. This is a cylinder that I just made out of paper. It does not have bases. As you can see, the bases on the top and bottom are not filled in. That's just like the capsule, because it has hemispheres on either side. So let's think about the dimensions. I am going to cut this open. Okay, so look at this. The distance around this circle right here, the distance around from this point all the way around the circle back to this point, that is the circumference of the circle. So when I open it up, I'm going to cut here. When I open it up, this part that was folded, this is the circumference of the circle. So this is the circumference of the circle because it was rolled up into a circle, and this was the height. Let me do that one more time. So you can see the circumference of the circle, which is the distance around, and as you can see, this is the height. And when I open it up, the height remains the same, and this distance here, this is the circumference of the circle. So basically, if I draw this rectangle here, I know that my height is 18. I'm sorry. My height is 14, because that's what it tells me in the problem. And this distance is the circumference of the circle. C equals pi times d, or C equals pi times 6 in this case. So my area of the curved part is the lateral area equals length times width, because it's a rectangle, 14 times the circumference, which is 6 pi, which equals 84 pi. So my surface area, or my lateral area only of just the cylinder, is 84 pi. So my surface area of the entire capsule equals 36 pi plus 84 pi. When you add those together, you get 120 pi. The units are in millimeters squared, square millimeters, because we're dealing with area. If we want to get a decimal, we are going to multiply 120 times 3.14. And we get 376.8 square millimeters. Okay, in part B. Part B asks, what is the volume of the capsule? Well, same thing as above. We don't have a standard shape. This shape is made up of multiple different shapes that we know. It's made up of two hemispheres and one cylinder. And as we did with the surface area, if we combine both of the hemispheres together, we get one sphere. So the volume of this entire capsule is the volume of one sphere plus the volume of the cylinder. So this is actually a little bit easier than the previous problem. The volume of a sphere, the formula is V equals 4/3 pi r cubed. V equals 4/3 pi r cubed. V equals 4/3 pi. Now r is, again, same thing as it was before, 3. So this is 3 squared. I'm sorry, 3 cubed. Take it one step further. 4/3 pi. 3 to the third power. 3 times 3 is 9, times 3 is 27. And then when we multiply, 4 times 27 is 108, divided by 3 is 36. So the volume of the sphere is 36 pi. And we know that the sphere is divided in two, one hemisphere on the left and one hemisphere on the right. Now what about the volume of the cylinder? Well, the volume of the cylinder, the formula, we know that shape. The volume is pi r squared times the height. We know the radius and we know the height. So the volume equals pi, the radius squared, the radius is 3 squared, times the height is 14. So volume equals pi times 9 times 14. So the volume equals 126 pi. Now, so the volume of the entire capsule is going to be the sum of the sphere and the cylinder. So the volume equals 36 pi plus 126 pi, which equals 162 pi cubic millimeters, because we're dealing with volume. Now if I wanted to change this to a decimal, I could, depending on how the question asked for the answer. It would just be 162 times 3.14 equals 508.7 cubic millimeters. Either of these answers are correct depending on the format of the question.